Okay, here are our Mod 16 Part 2 notes. This is page 1 and 2. It says 3 pages, but the last page is blank, so I'm going to ignore that part. You'll notice here that the example is typed out on the second page, so I can talk you through it without forgetting to say what I need to say. So now we are going to talk about 2 sample hypothesis tests for mean. So same thing we did in 16, part 1, but we're dealing with means here instead of proportions. As with the hypothesis testing for a single sample mean, we are going to focus on critical value because the rules for p-values here would require downloading a statistical package in Excel. No reason to do that when we can just compare the critical values and not worry about the t-values, okay? So just so you know for the tests, yes, anything that has to do with a sample mean will be done using the classical method, and our sample proportions, we can use the p-value method. So we have 2 different types of samples that we're talking about here. Independent samples, dependent samples. We will focus on independent samples here. A dependent sample would be when we have a matched pair, kind of a before-after situation, all that good stuff. Okay. Here is our table for how we're going to set these up. So our null hypothesis, our H naught, is always going to be that the 2 sample means are equal. So the mean for sample 1 is going to equal the mean for sample 2. Again, remember that we use X bar for the sample means, but we are looking at these as representative of a population, which is why we have mu sub 1 and mu sub 2. Okay. We are going to reject H naught, and this seems to be a question that's coming up, whenever the test statistic falls into the rejection region. So we're going to be very intentional about drawing that normal curve, okay, and not worrying about whether it's supposed to be above or below, but taking a look at whether or not it falls into that rejection region. So same 4 steps. We're going to state the hypothesis, the rejection rule. We're going to calculate our test statistic. But we are going to ignore this part. Obviously, I forgot to take that out when I updated the notes. And then we're going to state our conclusion and interpret that. So our 2 sample t-test statistic comes from subtracting those sample means and dividing by what is a pooled sample standard deviation. So the sample standard deviation from the first sample squared divided by the sample size, and the sample deviation of that second sample squared divided by its sample size. Okay. And there's our note about p-value. So here's our one and only one example, typed out for you so it's a little easier to read, hopefully, and follow. And I changed part, but not all. So we are going to study the difference in body temperatures in males and females. We've got 2 random sample of 65 females and 65 males. So I'm going to make sure I get all the female data in green here. It was found that the sample mean body temperature of the female sample was 98.394 with a sample standard deviation of 0.743. So if I go down to step 3 and look at my test statistic, my female is my X sub 1 bar. Here is that value, 98.394. I've got the sample standard deviation from my female sample divided by the sample size. We also have 65 males. Mean body temperature for the male sample was 98.105 with a standard deviation of 0.699. There we go, 98.105. Here is that sample standard deviation squared divided by that sample size for the random sample of 65 males. Okay, now let's talk about the rejection rule because I need to amend this as well. Here is my normal distribution, and I think when I made my answer key for this originally, I did not consider the different than, and I looked at greater, so ignore that for a minute, and I will fix it. I've got an alpha of 0.05. Remember that we want different than means this is a two-tailed test. So my alpha equals 0.05 gets divided into the two tails. So 0.025 here, 0.025 here. Both of those are our rejection regions. Guess I should say reject H naught. Okay. So we are going to reject H naught when T data is greater than I don't know why there's a random parenthesis here. And that is if our T data is positive or T data is less than T. If the T data score is negative. And I think when I cranked this out, I found a test statistic of 2.28, which was positive, so I automatically just focused on the positive part. But we definitely want to acknowledge that we're going to reject if this lies in either of those regions. Okay, now, to find that T critical value, remember there are two ways, if we've got a difference, to find the critical value when we have a probability. I can use T dot inverse. Again, my test statistic is positive, so I only focused on that positive and that 0.975. Or we can use T dot inverse two-tail and just use that whole alpha. So this here is alpha, and this is 1 minus alpha divided by 2 because we are dealing with that positive n. Anyway, you will notice that the degrees of freedom here is 128. When we've got a two-sample test, we find the degree of freedom by adding both of our sample sizes together and subtracting 2. So in this case, we had 65 plus 65, 130, minus 2, which gave us the 128. Okay. Now notice, our test statistic, our 2.28, see if I can find the most obnoxious color to write it with, lies over here. Because it is greater than our critical value of 1.98. So we are going to reject H naught. Our test statistic is far enough out into the tails that we can support the fact that it's probably different than the norm. Okay? So here is our conclusion. Again, 4 parts. We got to reject H naught, state whether there is or is not enough evidence, state the significance level, and then state what it is we were showing.